Thank you very much for inviting me for this very interesting workshop. And my talk is just a continuation of Dima's talk about minimal models, and based on the paper with Igor Klebanov and Dima Son. As Dima said several minutes ago, 40 years ago, it was so-called 2D conformal revolution. What should I do?
I'm just saying, like,
Yeah, it's not.
it's not going well. It's too bad.
Oh, cool. Yeah. Yeah, because the first line was the most important. The blind Polyakov Zamolodchikov found an exact solution to an infinite class of 2D CQs and minimal model MPQ with coprime integers P and Q and central charge, which is shown here. As Dima said, that 2 years after Zamolodchikov proposed the Ginzburg-Landau descriptions of A series of unitary minimal models, which are just multicritical Eisen models. These models have Z2 symmetry phi 2 minus phi, and also we have gel descriptions of D series of unitary minimal models. For example, for M56, it's 3-state pulse model. We have this gel description, and for another more higher unitary minimal models, we have multicritical pulse models. And this model has more difficult S3 symmetry with semi-product of Z3 and Z2. Okay, but what about non-unitary minimal models? No, it's not working. It worked before, but after now it's not working.
I think you didn't click the button.
Yeah, but what about non-unitary minimal models? It was a Strings 2025 conference in which one of the best scientists of the world asked different questions in the after session 2, and Igor asked exactly this question. And so what we know that for M25 minimal model, it's a cubic model, as Dima said. Also, Dima, his talk, explained us why M8 minimal model is two-field cubic model where we have G1 and G2 are pure imaginary. And in my talk, I will try to generalize this proposal for Ginzburg-Landau descriptions for a whole infinite class of Q, 3Q plus minus 1, where Q is odd integer number. And yeah, this model also has Z2 symmetry, phi to minus phi, and PT symmetry. Sigma goes to minus sigma, and I goes to minus I. Let me consider the one of the Nakayama flows, K equals 3, I equals 1 Nakayama flow from MQ 3Q plus 1 to MQ 3Q minus 1 minimal model. We can take large Q limit. In this limit, we have central charge approaches -7, and difference between central charges in UV and IR theory is written here. So it's something like -32 over 3Q in the large Q limit, and it's less than 0 because it's usual for the non-unitary minimal models where C theorem is violates, but C effective theorem, of course, it doesn't violate. And operator which is generates this flow is 517. So we can find a dimension of this operator in UV theory. It's slightly irrelevant because it's 2 minus something over Q, and in IR it's slightly irrelevant because it's 2 plus something over Q. So everything's okay. And our proposal is for this series that it's also two-field model, but Q, but power is not 3, but it's Q. Yes. So for example, the next example is 514 minimal model, and we have sigma to the 5th minimal model.
This one will be Now it just did four.
No, it's not working. Again, it's one thing. Yeah, and upper critical dimension of this series is 2q over q minus 2. Yeah, so let me consider the field identification in this Ginzburg-Landau proposal. In MQ 3q minus 1, we have the two even operators, for example, 5 on 3. And we're saying that 5 on 3 is sigma because it's PT odd and it has minimal dimension. 5 on 5 operator we identify with I sigma squared plus I phi squared. It's also PT odd. And this field perturbation by this field makes field sigma massive. And after the integrated sigma out, it gives unitary potential q minus 2. So this 5 on 5 operator again generates flow from MQ3q minus 1 to q plus 1. And 5 on 7 is one of the linear combinations of this sigma to the q plus what I wrote before. Yeah, it's 5 on 7 and it generates flow from from MQ3q plus 1 to MQ3q minus 1. Yeah, and for MQ3q plus 1, we have the same identification for 5 on 7, but another identifications for 5 on 5, 5 on 3. You remember Zimason's talk where he considered M3H. M3H is Q3Q minus 1 and M310, MQ3Q plus 1. And these identifications corresponds to his talk, but it's like a generalizations of what he said. And also in both Q3Q plus minus 1, this series contains zeta odd operators, and only one of the scalar operators 5 minus q minus 1 over 2 has negative dimensions. So we're saying that it's phi operator because it's PT even, but it's zeta odd. And why are we considering every time this series? Because in two-field model we have two fields. So we have spin one current. It must be primary, but we don't have primary operators, primary spin non-zero operators in A series. So this series must be D series, and this is identification for this spin one operator. Okay, let me consider the first example beyond the cubic model, the n=1 quintic theory, which has three terms: sigma phi to the fourth, sigma cubed phi squared, and sigma to the fifth. Beta functions are known only up to one loop or only up to the leading order. It's very interesting that theory maybe looks very simple, but beta functions are known only up to the leading order. So it's an open problem how to find next order beta functions. And at the leading order, this flow is gradient. That means the beta function can be described as gradient of C function. As you can see, beta 1 is the derivative of C with respect to G1, with respect to G2, and with respect to G3. So we can find the C function. By obvious reason, we call it the C function because in the Zamolodchikov paper about C theorem, he did the same. So we have this C function for this theorem. Yeah, and we can find non-trivial pure imaginary fixed points, just taking beta functions equal to 0. We found 2 points. Yeah, and it's very natural to say that the first point is the first minimal model and the second point is the second minimal model. So the first point is M514 minimal model, and the second model is 516 minimal model. But we calculated the stability matrix, and we was surprised that it has 2 positive eigenvalues for both fixed points. So that means that in the both fixed points we have 2 irrelevant directions. Of course, we expected to find that one relevant field becomes irrelevant in the IR, but this flow is not so short as flow from M310 to M38. So we think that we have in the UV theory, one of the irrelevant operator is almost marginal, it's almost 0. So we think that during this RG flow, firstly, it's starting to become relevant, and after in the end of this flow, it becomes irrelevant. So this we're not sure about. Yeah, but yeah, we have this identification, and as you can see, C function in the IR is more than C function in the UV. Again, C theorem violated, but It's non-unitary flow, so it's okay. We expected this. Yeah, here I listed properties of fields in M514 and M516 minimal models. So we have scaling dimensions. We have Z2 symmetry and PT symmetry. Yeah, but the D-series model invariant partition functions are here. They're very maybe similar to what Zima showed. This is like M310, this is like M38, but of course more difficult. So again, we have fields from Z2 even sector, and we have fields from the twisted sector. And just substituting Q equals to 5 in this slide, we obtain in this slide. Yeah, so all of these identifications which I explained before are here for M514 and M516 minimal models. Yeah, and what can we do later? Firstly, we're not sure even about M2Q minimal models and another minimal models. So we can try to find Ginzburg-Landau descriptions of all these models. And also we can, maybe someone is interested to renormalization of quintic theory up to the next order, because only the first order is known. Thank you very much. Maybe you have any questions.
Thank you very much for interesting talk. We have a couple of minutes for questions.
Questions for Zima?
Yes, it's not quite related, but suppose we want to construct another network for general people material. Is there any guiding text for how many fields?
Yeah, it's a good question. How many fields? Of course, if we have A series, we can't have more than one field. Yeah, because if we have two fields, we have spin one current sigma dm phi minus phi dm sigma, which can't be non-primary. So it can't be A series. It must be D or E series. So I think for all of the A series, we must have one field. Yeah.
You have A series.
Yeah, A series one field, but your question maybe how many terms in the Lagrangian, yeah? Yeah, of course we don't have. I don't think that it would be a good function of P and Q number of terms. Yeah, of course I thought maybe about this. Yeah, because I think maybe a lot of series will be just one term, like pi to the 0th power. It would be maybe infinitely many minimal models will have only one term. Yeah, but all of the A series will have one field. Yeah, so I don't have any proposals, of course, for any MPQ on breakdown. It's a good question to think about.